Hello everyone. In this video, we're going to solve some questions about finding the derivative using different formulas. I hope you had a chance to see the previous video about all the derivative rules, and we asked ChatGPT to provide us the sample of some complex questions of the combination of different rules using polynomials and also trigonometric functions. We're doing one by one. The first question is the multiplication of a polynomial and cosine. We're using the product rule. And what is the product rule? I just write the formula here. H of x equals f times g. This is the function, so h prime will be the derivative of the first function multiplied by the second function plus the first function multiplies by the second derivative. Okay, so now f prime here will be the derivative of the first function, which is 2x, multiplies by the second function itself. We don't need a bracket here. You can use cosine 3x as well. Plus the first function x squared plus 1 multiplies by the derivative of cosine, which is negative 3 cosine. So this will be sine, so sine 3x. So we're using the formula here, cosine u. Derivative of cosine u will be negative sine u times u prime. So when you have cosine 3x, 3x is u. So it means the derivative of the base will be negative sine 3x, and then it is multiplied by the derivative of u, which is 3. And this will be negative 3 sine 3x. You can simplify this as much as you can. So this will be 2x cosine 3x minus 3 times x squared plus 1 times sine 3x. Next question is about quotient rule using tan and the quadratic function in the denominator. We're using the quotient rule. And it is h of x equals f over g when g is not equal to 0. So h prime is the derivative of the top times g minus f times g prime divides by g of x to the power of 2. So now you see here the top function, for example, assume that this is h, tan is f, and x squared plus 4 is g. It's a quotient. So we're using the formula h prime or f prime equals the derivative of tan, which is 1 plus tan squared x, and the u is x here, multiplies by y, u prime is 1, times the denominator x squared plus 4 minus derivative of bottom times the numerator, so it is 2x multiplied by tan x all over x squared plus 4 to the power of 2. You can simplify this more. This will be x squared plus 4 plus x squared tan squared x plus 4 tan squared x, then minus 2x tan x, all over x squared plus 4 to the power of 2. This is the final answer. We cannot simplify this more. The only thing I'm gonna add here is about 1 plus tan squared x that can be written as secant squared x. That's it. The only changes we can do it is using secant squared x instead of 1 plus tan x. Question number 3 is the square root. And you see the hint here. We can convert the radical to the rational exponent. We're using this formula. For example, when you have root n of u to the power m, you can write this as u to the power of m over n. So the exponent goes to the numerator and the root goes to the denominator. So it means any radical with any root or power under the radical can be written in this form using the exponent in the fractional form. Okay, now we're going to use the chain rule. And if you remember the chain rule for u to the n, if you want to take the derivative when u is another function, the derivative of this function is n, u to the power of n minus 1. So far, we're using the power rule, but because u is another function, so we should multiply this by the derivative of u as well. In our example, what you see in the bracket is u. So means here we have u to the power 1 over 2. So what is the derivative of this function? It's going to be 1 over 2 u to the power 1 over 2 minus 1 and multiplies by u prime. Now we substitute the value of u and u prime here. So it is 1 over 2, u is 4x squared minus x plus 1 to the power of negative 1 over 2, and it is multiplied by u prime, which is 8x minus 1. You can move it to the denominator to see the radical form and also the positive exponent. So it can be written like this: 8x minus 1 divides by 2 square root of 4x squared minus x plus 1. So we mostly convert the negative exponent to the positive exponent. If you move this to the denominator, then the exponent will be positive. That's about question number 3. Question number 4, 5, and 6. For question number 4, we're using the derivative of sine and also the product rule. The product rule is, for example, when you have the multiplication of two functions, h prime will be derivative of the first function multiplies by the second function plus f of x multiplies by g prime. We also have sine, and what is the derivative of sine is going to be cosine x. U is x here, derivative of x is 1, so you don't need to multiply by u prime. Another notation that you can use instead of using prime, so you can write d of sine over d of x, which is cosine x. This is the notation that we use when we differentiate the function, but the concept is exactly the same as what we do in the derivative. Now we have the multiplication of two functions. So f prime here is the derivative of the first function. We are using the power rule. It is 4x minus 5 multiplies by the second function plus the first function 2x squared minus 5x times cosine x. You can expand both brackets to find the final answer, but this answer also will be acceptable because there is no more simplification that you can apply here. Just you can expand the brackets and that's it. Okay, in question number 5, we have the multiplication, also cosine, we're taking derivative of cosine, and also there is a quotient rule here. We have a mix of all. First of all, we apply the quotient rule. And then when we want to take the derivative of top, we should use the product rule. So f prime here is the derivative of numerator. So it's going to be x squared times cosine x. I'm using this prime here. And I will take the derivative in the next step. Multiplies by the denominator. Minus the derivative of denominator 2x times top, x squared times cosine x, and then divides by x squared plus 1. Now we have the product of x squared and cosine x in the top, so we should apply the product rule for here. It's gonna be the derivative of the first function. I'm using the square bracket, which is 2x times the second function, plus the derivative of the second function, which is negative sine x times the first function. It's gonna be negative x squared sine x times by x squared plus 1, and then the rest is negative 2 x cubed cosine x. Divides by, okay, my bad, this should be x squared plus 1 to the power of 2. We're using the quotient formula, and in the bottom we have the square. So now we can expand the top and simplify this as much as we can. It's gonna be 2x cubed cosine x plus 2x cosine x minus x to the fourth sine x minus x squared sine x, and then minus 2x cubed cosine x, all over the square of x squared plus 1. And as you see in the top, these terms are cancelled. So the final answer will be 2x cosine x minus x to the 4 sine x minus x squared sine x, and then divides by x squared plus 1 to the power of 2. I hope that makes sense. Let me know if there is difficulties here, or if you need more explanations in each formula and in each example. Okay, we're going to the next one, question 6 and 7. We should write the new formula here. We have sine to the power of n of u. How do we take the derivative of this function? It's a kind of power rule here. This will be n sine to the power of n minus 1. And then we multiply this by the derivative of the base. The base is sine u without the exponent. What is the derivative of sine u? Is going to be cosine u times u prime. So this is a formula that can be used for any quadratic functions when you're dealing with the powers and also the chain rule. So now here, what is u? U is x squared plus 1 and n is 3. So we have sine to the power n of u. And we're using the formula f prime will be n is 3 here, sine to the power of n minus 1, so sine squared u, multiplies by the derivative of base, which is cosine u, and then it is multiplied by u prime, so this will be 2x. So you can multiply 2x by the 3 coefficient here, and it's gonna be 6x multiplies by sine squared x squared plus 1 times cosine x squared plus 1. So just as an example, or for your practice, you can try to find the derivative of these formulas here. For example, try to find the derivative of cosine u to the power of n. Also, you can try tan u to the power of n. Second, u to the power of n, and also cosecant. Don't forget to take the derivative of cotan u to the power of n as well. So the only thing you need to multiply for each formula here is n times the function to the power of n minus 1. And the base is the same as the trigonometric derivative, and you can use the same formulas here. Question number 7, we have the radical in the top, also the quotient rule. So f prime here is the derivative of the numerator. We're using prime here and take derivative in the next step. Multiplies by the bottom minus derivative of bottom 3x squared multiplies by the top, divides by x cubed minus 2. And how do you take the derivative of this function here? if you write x squared plus 3 to the power of 1 over 2, is going to be easy. We're using the chain rule formula. This will be 1 over 2. X squared plus 3 to the power of 1 over 2 minus 1. And it is multiplied by the derivative of u, which is 2x. So you're going to have, this 2 will be cancelled by 1 over 2. You're going to have x over a square root of x squared plus 3. So this exponent will be negative 1 over 2, but we move it to the denominator to make the exponent positive. This is what you need to replace in the first term in the top. This will be, okay, x over a square root of x squared plus 3 multiplies by x cubed minus 2, and just write the rest of the answer. Don't forget to write the exponent in the bottom. In the quotient formula, we have gx to the power of 2 in the denominator. Okay, there are three more examples, question 8, 9, and 10. In question 8, we have the multiplication and also the chain rule. So f prime here will be derivative of the first function. So this is u to the n. Derivative of this function will be n u to the n minus 1 times u prime. So what is u here? U is x squared plus 1. So the derivative of the first function is 2 times x squared plus 1 to the power of 1, and then multiplies by u prime. This is the derivative of the first function, which is multiplied by the second function, and then plus derivative of the second function. Here we have cosine v. What is derivative of cosine v is going to be negative sine v times v prime. Okay, so we use the same formula here. It's going to be negative sine x squared multiplies by 2x, v prime is 2x, and then multiplies by the first function. So this will be 4x times x squared plus 1 cosine x to the power of 2, and then minus 2x multiplies by x squared plus 1 to the power of 2 times sine x squared. So pay attention here. This square is on x. It is not on sine. It is the exponent of x here. Okay, question number 9. We have the product rule in the top, and also we have the quotient rule. So f prime will be derivative of the top multiplies by the bottom minus derivative of the bottom I'm sorry, multiplies by the top, and then all over root x squared plus 4 to the power of 2. Let me take the derivative of these functions separately. X times sine x prime is going to be the derivative of the first function times the second function plus derivative of the second functions times the first function. So this will be sine x plus x times cosine x. Also for this function, x squared plus 4, we can write this with the rational exponent, x squared plus 4 to the power of 1 over 2 prime. And we're using the chain rule. It's going to be 1 over 2 x squared plus 4 to the power of negative 1 over 2 times u prime, which is 2x. 2 is cancelled by 2, and we move it, the negative exponent to the denominator to make the exponent positive. Now you can sub in the calculated derivatives into the final answer. So we have sine x plus x times cosine x multiplies by root x squared plus 4 minus derivative of the top is x over root x squared plus 4, we already calculated, multiplies by x times sine x. And then all divided by x squared plus 4. You can distribute the bracket in the top and then just make it maybe simpler, but I don't continue this exercise because I don't think there is any common terms that can be cancelled, or we can show this simpler than what we are seeing now. Okay, and finally the last question is again cosine u, and here u is 2x squared plus 3x to the power of 2. And what is the derivative of cosine u? It is negative sine u times u prime. I don't think these are the same. These are not equal because I see this exponent on the top of the bracket, not on cosine, and these are not equal. So to me, the hint here is wrong. So we're using the function and we're using the formula to take the derivative. F prime here is negative sine u and then times u prime. Now for u prime, we should take the derivative of this bracket. We're using the chain rule. It's going to be 2 times 2x squared plus 3x multiplies by the derivative of what you have in the brackets, 4x plus 3. This is the derivative for question number 10, but if we expand the hint here, cosine x, cosine 2x squared plus 3x to the power of 2 is different. So the derivative of this function is going to be 2 cosine 2x squared plus 3x, and then multiplies by u prime here. Okay, the base is negative sine, so it's going to be negative sine 2x squared plus 3x. And it is multiplied by 4x plus 3. and you see these are not the same. So pay attention when you have cosine x squared, it is not equal to cos square x. These exponents are different. One of them is on the function and the other one is on x. I hope this video can help you for doing some complex exercises in derivatives using the formulas. And please put your comment, or if you have any questions, let me know. Thanks.